Welcome to today's Ascendo Reliability webinar event. We're going to talk about suppliers and the reliability of the bits and bobs and subsystems that they provide, and some of the good and the bad and the ugly kind of format today, but maybe not so much in that order. Let's see if I can get my slides to move forward. I didn't quite line up the images with my opening piece here, but as a consumer, as a person, I'm looking at a desktop computer, and it's probably likely that the name on the computer itself did not make all of the components that are inside this box. And years ago, I worked with Hewlett Packard, and I knew that we bought connectors, for example, from various connector suppliers and capacitors from various suppliers. And we bought power supplies from various suppliers. And every now and then, power supplies fail, for example, and capacitors and other components do. And as a consumer, being familiar with computers, I could have opened it up and figured out that the power supply had failed and that it was from XYZ company and called them directly. They were probably not set up to deal with a customer calling them directly about a unit they sold to HP, which then sold it to me. And so I called the nameplate. I called the logo on the side of the box or the company that I bought the system from. In some cases, I even go to the retailer. If for some products, I'll go back to Best Buy or the box store or wherever I bought it and say, hey, it's not working. Those are all fine things to do. It's just that the point is that as a customer, when an item doesn't work, we really don't care if it's a capacitor or a power supply or whatever it is. Well, this crowd does because that's what we do. But in general, we don't really care. It doesn't work. You need to make it right. And so we call the company that we have on the label of the box, on the side of the car or whatever. It's important because even though a supplier's component failed, the customer doesn't recognize that it's not working. If the plane doesn't show up because of engine trouble, we don't immediately blame Pratt and Whitney or GE or whoever made the engines. It's Boeing, or maybe it's even more importantly, it's the label on our ticket, which is the airlines. And it's a subtle point, but it's one that we have to keep in mind at all times, especially when working with suppliers. Remember that suppliers even have suppliers. And so we're all customers at one level or another, intricately part of it. But at the end of the day, the products that in use, when they don't work, it's the brand, the nameplate, the company that assembled it and boxed it and sent it to that user of the products that is on the hook to make it right. Now, we make products. We make systems and products and production lines and all kinds of cool stuff, and we buy elements of that. So if we're doing a bottling production line, we buy a bottling machine, probably custom made for our particular circumstance, and installed in our factory. When that fails, we can't fill bottles. And so and also our products themselves going out the door become delayed, and it's expensive when it fails. As a consumer, say of a desktop, if it fails, it's inconvenience at best, and it's business trouble if it lags too long, it takes too long to get it up and running again. But our products are purchased because they add value to the person purchasing it. Right? I don't buy a bottling machine just because I think they're really cool, which they really are if you've ever been up close to one of them. You're not going to go spend $10 million just because it's cool. You're going to spend $10 million because you're going to make money more than that investment in an efficient way over time that more than pays for that $10 million piece of equipment. and it allows you to create the beverage that you're producing and be able to sell it in a cost efficient way. The products we make have to add value and have to meet a need or solve a problem for whoever is purchasing it. And part of that is the design and the branding and the selling and all that good stuff. And it used to be that products, I'm thinking of the early Ford Motor Automotive Company in Detroit, they owned their own iron ore fields up in northern Minnesota. And they owned the barges and boats that took the ore to a smelt, which they owned, which then created the metals that they wanted. And they owned forest for all the wood products they were using on dashboards and steering wheels and stuff like that. They were totally vertically integrated. Now, there were people making steel at the time, but they wanted it under their own control and to meet their own demand. So they were called vertically integrated. They did everything themselves. I mean, including putting, pencils together and stuff like that. It was amazing how integrated their whole system was. Early days of Hewlett Packard, when they were doing primarily test and measurement stuff, they made their own screws. They found it more cost effective for them to do it themselves to get the quality of fasteners that they wanted. And so they had a small team that produced screws for all the other products that we're making. But today, it's not so vertically integrated, right? We have people that make screws and they're really, really good at it. And they can do it so much more efficiently, including the shipping times and costs and so on, than we can. And so we buy it from them. That's their product. Now, the motivations for creating screws may or may not be the same as where you're putting them, how you're using those components. So we'll talk about how the forces of the product customer relationship changes as your different parts of the supply chain. And of course, there's suppliers. They're the people creating things. And I once worked with a company making inductors, little wire wrap magnetic devices that are used in electronics. And their catalog had thousands and thousands and thousands of styles of these inductors, all different sizes and shapes and capabilities and values and so on. And part of the question was, how do they make them more reliable? And I says, well, where are they being used? And they just kind of looked at me like, well, everywhere. Anywhere there's electronics, there's probably an inductor in there someplace. And they're in space, they're in oil wells, they're in satellites, they're in your car, they're in your home electronics, they're just about everything that has electronics has their things in it. I says, well, do you have different grades or styles or things for different kinds of environments? And they go, not really. Most people just open the catalog and buy the inductors they want. And rarely do we get a request for, say, a radiation hardened one, which there's not really much they can do to make it radiation hardened. And I'm like, oh, okay. So they just work wherever they are. And then they said, well, sometimes they work better, in a benign environment than they do in a very hot environment or a vibration environment and so on. So they were pretty blind to where their products were actually being used, other than just everywhere, which doesn't really mean a whole lot. They weren't designing for the edges. They were designing products that worked. And over time, the suppliers reacted more and more to the cell phones and portable devices, so making things smaller and cheaper and so on. But they didn't have a military grade setup. They said, no, they're not big enough of a market, and we don't do the extra testing they would expect. So we just don't do that part anymore. But the key point was, as the suppliers, the many suppliers I've worked with over the years, it's rare, unless they're doing very custom type work for specific buyers, it's rare that they fully understand how their products are being used, which makes it really tough to have a very reliable system that you're producing or product you're producing as a supplier if you don't know the environment and use cases that it's undergoing. So it's a blind spot for them. They know it, and it's just part of their business in too many cases. We'll talk more about that in a little bit. So, how many suppliers do you have with the products you work on? And this is kind of a rhetorical question because there's probably more than you think. Uh, and yeah, we get involved with handful of key suppliers or critical components or suppliers with systems that aren't working for us or we have trouble with, and we get in touch with them. We may get involved in some organizations. I know I got involved as a reliability engineer with some suppliers as a part of supplier selection. We had 4 or 5 that were likely suppliers for a system that we wanted to put together or a subsystem we needed. And reliability was an important factor of it. So we would be part of the team assessing the supplier's ability to meet our needs. But that never went to all of our suppliers. Now, I know a good number of you on the line today are experienced and have more than likely experienced a failure in your product that was not your design problem, not your manufacturing problem, not your tier one or primary suppliers, not their problem, but maybe a component that went into one of your suppliers' systems. And the one that jumps to my mind is this is decades ago, but the little plastic, the black encapsulated polymer that goes over some ICs and various components, electronic components like linear regulators and things like that, has a flame retardant in it. And it's pretty corrosive stuff. And it's usually bound up pretty well in the epoxy, so it doesn't get loose and go corrode other things. Well, it turns out that the people that made that flame retardant material changed the size of their screens when they were sifting the stuff to be a certain dimension of grain size for the final product. They made it a little bit bigger, just a little bit. And their thought was, well, we can have a higher yield. It improves our throughput, does a bunch of other good stuff on it. It's still the exact same compound. And that size grain was more likely to not be fully encapsulated by the epoxy. And then you put it in a vibration type environment and they would vibrate loose, these little grains of pretty mean corrosive type material. And of course, it fell right on the leads of that component and created shorts and all kinds of other problems and caused raged havoc. And it turned out it wasn't the epoxy maker. They blended the, so there was a manufacturer of the flame retardant. There was a manufacturer of the epoxy that incorporated that flame retardant. And then there was the packaging house that, you know, built the IC and encapsulated it in this epoxy. And they were our supplier. We bought their components. And then the customer got a server, in the particular case, that soon thereafter failed. And it was the supplier's supplier in that case. Now, I'm quite sure they had suppliers to get their raw materials and the equipment they used and so on, including those screens they swapped out. But in our design efforts, we rarely go to suppliers. It's in some cases you may, in some very sensitive types of systems you may, but it's pretty rare. And the chance that we even know who are all of our suppliers is also pretty rare. All right. So let's do some good news a little bit here. There are really good supplier customer relationships or supplier manufacturer relationships. And I've been a part of a couple of those. what I call a perfect relationship is that you can reach out to, say, your supplier. I would say it's a connector, and just as a something we can visualize. And they could give us off the shelf standard connectors, or they can customize them. They can design them for us. They have lots and lots of options and lots of capabilities. And when you get together with that team, and it's not, the initial content is not a salesman that says, we can solve whatever problem you have as long as you use one of our parts. And instead, I've been in part of a conversation, and it wasn't for connectors, it was a different component, but they asked really good questions about where and how we're using it, what were the demands on this component, and where, how was it used and stuff like that. And they asked really good questions about it. We talked about some of the trade-offs and the design and what the options were and what we're considering, what was the function we're looking for. And they said, we really don't have a component that does that. You should try these guys. They're really good. And they sent us to another supplier to solve the problem. But they started with the discussion of what exactly are we trying to accomplish, rather than which of our many parts will solve your problem. Maybe. They were not selling only themselves, they were selling a solution, and they helped us to get to it, even if it wasn't their own catalog. So that was very interesting. And then we worked with them many times in doing design work for custom stuff and pulling stuff out of their systems. But it was always with this understanding that we weren't just being sold what they had. We were working together to solve a problem, to create a design that would work for both of us. They didn't want their products to go into something that was just going to be a bunch of calls for saying, hey, it doesn't work. And why is this not working? That's expensive for both parties and usually not a solid way to build a relationship. So they really worked very hard right up front to understand, will their product work in our system or not? And when they got into custom design stuff, it was like an adjunct to our own team. They were as if they were engineering team right on our design team, and worked very closely with the design teams to fully understand how and where it was used and how it was working and how it might fail and what kind of things to look for. How do we do the testing for it to make sure it's good on both sides? And we worked together to create a really strong, reliable solution. Now, this may sound like fiction to some of you, but it can happen. The other part that came out of this is that even having that relationship right up front, that we're going to understand how and where this is going to be used, is this one team that I was working with that also said, well, when we asked, so how is it likely to fail? And we actually did an FMEA with them. It was a critical component for us. And so we did an FMEA with them as they were working with us. And they were very open. Well, if it's under these circumstances, the way it's being used and so on, we expect this and this failures, and this is from our experience. And here's the physics of failures type discussion about how and why we think that's going to be the problem. And these other mechanisms are, no, we don't think they're being treated pretty softly. I think they're going to last a long time. And here's some evidence. Here's some work they've done prior and stuff like that. And they didn't hide anything. They said, in your situation, this is likely to fail. We think it'll be good enough. And here's the testing internal data that we have. And here's how we went about doing it. And we reran the test. This was really a critical piece for us. So we did some accelerated testing with their help to fully understand how to do it, and got pretty decent results. So we ended up using it. But when we did have a failure, and we saw some of that in our prototyping, that it was, they said, we don't have the X-ray machine. Do you have one? Do you have access to one? Let's get some imagery of that. That might help us sort out this problem quicker. So we had some resources and equipment that enabled them to get a deeper dive into it. They had some equipment and techniques that we didn't have. So we first started with saying, like in a good failure analysis program, it was, let's work together to solve that problem. Let's work together to truly understand it, as opposed to when it's not good, which we'll talk about here shortly. It was done efficiently. It was engineer to engineer in many cases, and it was done with very open discussions about getting it right. And it was with that backdrop, the relationship was, if our components and materials are successful in your system and it's successful, we both win. We get to make and sell these things, and you get to make and sell your thing. And that is such a fragile relationship, I have found. Even though when you get it started, either the lawyers get involved, or procurement gets involved, or a bean counter gets involved. No offense to the finance folks, but then it shifts to a completely different tone to the relationship. And I think I spelled relationship wrong, but that's just me. It might not be. But the idea is that if you start with a solid understanding and discussion, and it does take time on both sides, and it's not done with every supplier that you have, but for important pieces or critical pieces or core elements of your system that you have to get a supplier to get create it for you, having that very open and clear discussion right from the get-go sets up a relationship that allows you both to be successful. And I think I already talked about this a little bit, is the failure analysis process. There was it was before my time at Hewlett Packard, but it was with the LaserJet folks out of Boise, Idaho. There's a division up there that they had the print engine, I think was from Canon. I'm not exactly sure, but it was a Japanese organization. And the rest of the printer was HP design and branded. And when something went wrong with the printing mechanisms, the actual deposition of the ink, or not ink, it was toner onto paper, that was that supplier's part and parcel. And we found out, well, I wasn't there. The team found out very quickly, just saying, hey, this isn't working, and shipping it back to them really wasn't getting anywhere. And so what the team in Boise did was they did the first level of failure analysis. They started really analyzing it and doing the where exactly is the failure? What is it, a temperature thing? Is it a whatever it was? They went into detail and really learned that their component, they're part of the system. But we had really good failure analysis, chemical labs and physics labs and so on. And then would ship it over to the supplier and say, hey, this is what we found. And they would go, yes, we know how to fix that. Whereas if we just shipped in the broken units, it would be months and months and months. And it turned out it was a difference in culture. The US team was much more inquisitive and willing to just try it and take it apart and break it and see if they could repeat it. Whereas the Japanese team really didn't have a process for that creativity piece of it, of the failure analysis. If they understood the problem, they could solve it. They were very good at that. But finding the failure was just not something they were good at. And it was the particular teams we were working with. So they very quickly set up this relationship where instead of just saying, hey, it's not working, fix it, is like, here, let's work together to understand the problem. We've got the tools and techniques to do it. And then they said, oh, great, we know exactly how to fix that. And they would, and we were off and running again. And so it was a very cooperative failure analysis. And it's a hallmark of a really good relationship with your supplier when that can happen. Unfortunately, it doesn't always happen. So I don't know, I should pause here for a second and say, in the chat, Do you have any, or have you worked with any what I call perfect suppliers? And I'm not counting the ones that we never have problem with and wouldn't even know their name. We just buy it out of a catalog and zero. Sorry to hear that, Tony. They are out there, and sometimes they take a little bit of work, and we'll get into how to do that, make that more likely that you get to work with a perfect supplier. Yeah, they are out there. It does take a little effort though to make happen. So here's a typical relationship. This will be a whole lot more familiar to most of you. Years and years ago, I was with my boss and we were visiting a supplier, and I was tagged along because they wanted to know about the reliability, performance, and some of the manufacturing processes that we were going to use and make sure it was all going to work for us. So it was a bit reliability, a bit assembly. And my boss walked in before he even said hello at the first handshake. He says, "So how's the cost reduction going?" Now, we weren't procurement. We weren't in the procurement organization. We were designed for manufacturing and designed for reliability team. And the very first thing he asked was, "How's the cost reduction going? What's the schedule for cost reduction? When are you going to shave this price down?" When he asked it about 50 ways in the first hour, and he never ever mentioned what we were nominally there to do, was to check the manufacturing processes and looking for weaknesses so we could improve, and also looking at the durability, reliability characteristics of their, how do they know it's a good product? It wasn't until halfway through the second day before I got separated from him and was spending some time with a couple of engineers and got the questions I was after answered. But he was still hammering cost reduction the whole time. So from the supplier's point of view, here is this major customer coming in, and we're going to buy gazillions of these components, and just over and over and over again harping on about cost reduction. Just make it cheaper. It was just like, that was the total message. Oh, and by the way, Fred was here to talk about something else. And that was it. And from the supplier's point of view, they're going to hear that message loud and clear: cut costs. And the problem is that lower cost isn't always the best choice for a product. And it's also not always in the best interest of the supplier, right? They want to make money. They got to stay in business. And if they keep cutting their margins, eventually they're not a viable business anymore. And we need a viable business. And I learned this from some procurement folks, is that driving only cost is not always in the relationship's best interest. Yeah, we save money on our bill of material, yet, and I think I've told this story before a number of times, is that, yeah, we save a nickel on each component, but we spend 50 cents per unit that we ship because of failures. And so are we really saving any money on this? And so there's all kinds of stuff. So they, look for opportunities to reduce costs, to make their systems more efficient, do all those other things. But eventually they have to just move away from the product that we think we're getting. They're going to use different materials, different assembly techniques. They're going to use different requirements and internal specifications as a way to meet the cost expectation. And there are plenty of procurement teams and relationships that aren't driven just on cost. Yet, if you're in an auto industry, and you know that if that truck of bumpers doesn't show up on time, the line stops, and you know exactly how much that costs per minute of downtime. And some of those relationships even have penalty clauses that if you delay or stop the line from your component not being available, or just the time to market kind of thing, you're going to get fined for it. And so it turns into cost again pretty quickly. You're going to take the risk. We're going to share the risk of a downing event, and we're going to make sure that you pay your fair share or more of it so that you have a motivation not to take the line down for whatever reason. But a typical relationship I've seen is, oh, we're going to line up 3 or 4 vendors and make sure they're all can create the, provide the component we need. And then we're going to barter or banter between them. I guess that's not the right word. We're going to put them in a competitive state to see who has the best cost for the given requirements. And it's just sending the message that low cost, you get the business, and sometimes you really don't want that business because you don't make any money. And it's there's way too many procurement organizations that just set up structures that just go after cost. They say they're going to talk about all these other pieces of it. Yet when you're in the meetings with them or you're visiting the site, it's all about cost. And so the message gets sent very, very clearly. This just reduce the cost. And it's implying we don't really care about the quality of the product. We don't really care about this, that, or the other thing. As long as it's nominally works, we're good. And then when something fails, they don't have the staff. They don't have the investment anymore. They don't have the engineering teams to really understand how their products fail and what they can do about it, if anything, because that all costs money. And we've been saying reduce costs for the last 20 years. And so they just don't have the failure analysis labs anymore. They just don't. Now, this is the list I learned from Dick Moss when I was at HP. He says, yeah, I said, I'm having trouble with the supplier. They just seem not to want to help me troubleshoot this particular part. And he goes, what did they say? Did they say they've never seen that before? That was the first thing. And I called them back and said, oh, we know about that. We fixed it already. I misspoke earlier. And then it was, I had a FedEx package in the mail. I just put it in the bin that morning. I called the supplier saying it was coming in. And he says, oh, don't bother. It's ESD. Now, electrostatic discharge in electronics is really difficult to find, to prove that it is that. You see this little burn mark inside the ASIC, and it's really hard to discover where they are. And he was like, oh, it's ESD. Well, how do you know? He says, because it looks like this large burn structure, the burn scar has gone across the component. I don't think ESD had anything to do with that. We're running on 5 volts, and like, no, it's ESD. He was convinced. It obviously wasn't, but he didn't want to have anything to do with that. Just said, don't bother sending it. We know what it is. There's nothing we can do about it. Which goes into the more common one is, oh, well, you broke it. You must have dropped it. You must have did this or that, or it was misassembled. We don't have any control once you unpackage it. It's yours. It's not our fault, man. It's yours. And then you finally get the components there and you say, hey, how'd the failure analysis go? Oh, it worked perfectly for us, which may actually be true. When we isolate a component and send it back to a vendor, it's out of its environment of where it failed. It may be just working just fine, but it behaves in the circuit like it's not because of our circuitry, because something else failed. And usually it's some variation of, hey, it's not our fault. It's your fault. In variations like that. And part of that is a defensive relationship from them saying, we don't want to get into a failure analysis of this. That costs money. And that comes right out of our profits. We don't have enough margin to cover that kind of stuff. So we're going to deflect whatever we can. Now, if we gave them a decent price and worked closely with them, like in the Perfect Group, we wouldn't be having these discussions. It would be, oh, what's going on? What are the symptoms? How can I help? What do you know? What do you don't know? What can we do to troubleshoot it? As opposed to, no, it's not our fault. It's way too often. I don't know how many phone calls I've made to suppliers that I got this. And a variant of this was, oh, it passed all of our tests. I said, can you, this thing is a crystal. electronics component for a crystal for timing, and the crystal broke. The actual crystalline piece inside this metal box broke. And they said, well, that's not possible. They said, here's a picture of it. It broke. Then they got upset because I had cut the top off. I cut the box open so I could see the crystal. He says, it's broken. He says, well, it passed all of our tests. I said, well, please describe how you test these. Well, it's this IEC, this, that, the other thing, number 47, clause B, and you take a crystal, the little itty bitty component, weighs a few grams, and we drop it 3 feet onto plywood. Okay. And then what do you do? It says, well, then we make sure the crystal is working. We put it in a test rig and it works and it passed the drop test. Okay. How many times are crystals dropped all by themselves and cause, is that anything? Is that anybody ever do that? In manufacturing, maybe, but it's in tape drives. It's automated system. They're, pretty much fixed in place. And if they drop, we don't pick them back up and put it back in. In a product, it's in a circuit board. And there's a whole lot of other forces going on there. And at that point, they says, we don't do circuit boards. We make crystals. That's how we test them. They're like, okay, we're not going to get anywhere with this. So we went off a different direction, did the failure analysis ourselves, and actually went to a different crystal vendor at that point. I'm quite sure many of you got stories about variations of a typical relationship. And I should say, to be fair, is vast majority of our suppliers do want to do a good job. It's in their own interest to have decent products that people want to buy and use. It keeps them in business. And we never hear anything going wrong with those components. A good number of the components we have never have any problems. They just work. And if there's an issue, it's resolved pretty quickly. It's identified as a batch issue or something else, but there's plenty of them. And it was almost on a weekly basis when I was at Hewlett Packard in particular, that it was, hey, not our fault. We're not dealing with that. We don't have the money for that kind of stuff. And part of it might have been the aggressive procurement organization we had that was really pushing the costs. Well, we tried to change that at one point, and this gets into my last piece of the webinar, is you have to understand what's driving this. What is causing the typical relationship with suppliers, right? Some of it is our own bandwidth, and we end up getting procurement organizations that may or may not have any engineering talent on them, yet they're buyers. That's what they do. They go negotiate terms and conditions and delivery rates and shipments and shipping. And they take all the requirements we have for manufacturing or for the design and convey it to them. They even get upset if you go around them, if you talk to a supplier directly. That to them, it alters the relationship and they're not in control of it. Yeah, 9 times out of 10, it works just fine. We get capacitors and resistors and other components that just do the job and really don't cause any problems. And yet, when there is a problem, it devolves into who's at fault. And in some cases, it even goes all the way to a legal case. And some of the suppliers I've been involved with, it became, then once it got locked up by the lawyers, you never hear about it again. But the idea is that there are systematic things in organizations that causes this typical relationship to happen. In the bill of materials for most products is a very large cost of creating that product. There's design effort and time that's an investment. There's manufacturing people and equipment and supplies that go into it. But when you ship a component or a system out to your customer, typically the dominant element of the cost of that system is all of the purchase elements that you put into it, your bill of material cost. And so it's seen as this great big opportunity for cost reduction in a lot of organizations. And so I'd say more than half of the supply teams I've ever worked with were focused on negotiating the best price and negotiating cost reductions year over year. And they are also good at finding components, finding helping us find suppliers and vetting suppliers and things like that. Yet their primary function was cost reduction. And it wasn't balanced by anything. It was just get the cost reduction. It's something we can measure. It's a big bucket of money. We want to reduce it. Well, what would you do when you see a system that is driving a behavior that's contrary to creating a reliable working solution for your customers? Well, as a reliability engineer, there's lots we can do and should do. But the first part is recognizing those forces at play that are driving those behaviors, that are causing our own people in our organization to treat suppliers in such a way that they are not able to give us the right products and create the right solutions for us. Now, of course, there's lots of exceptions, but in general, there's usually these structural things that occur that cause this to happen. And anybody that's listening to me talk about suppliers at more than 3 seconds recognizes that if their motivation is cost reduction year over year, and they get paid for that, say in bonuses, that's pretty much all they're going to do. And it's unfortunate. So let's change that. Let's change the bonus structures so that it includes warranty costs. If the warranty goes up, you don't get your bonus. If the warranty is saving money and it costs more to buy the products, that's okay. And you hear lots of people talk about the total cost of quality or the total cost of components and systems. Well, let's include the things when they don't work. And it's a little harder to measure. It takes time. Yet at the end of the day, it's still money out the door that we could have avoided. And so by changing the bonus structure in one organization, it completely changed the motivation for cost reduction to include warranty reduction. Oh, all of a sudden they're on our team, and which was refreshing. All right, so how do we set up this perfect relationship? It's not magic at all, but it's sitting down and thinking through what is it we really need. Oh, we need a power supply that does this, this, and this, and it has this structure and framework and works worldwide and so on. We create a requirements list, say. And we usually work with procurement. Hopefully procurement engineering works closely with the design team. And we figure out which suppliers even can do this, which ones are candidates for doing this. And then you open a discussion with them and say, it's your first time buying power supplies for a new volume product that you're making. And can you do this? Now, good salesmen always say, yes, we can do that. They may have no idea whatsoever. So it starts that initial set of discussions is, we want a power supply that has a high reliability because we don't want to have to use a backup or redundant power supplies because of space constraints or other constraints. So we need it to work for 10 years in this environment. And being upfront about that, and it's very easy to tell if you're talking to the wrong person, their eyes glaze over. They go, oh yeah, all of our products just work. They're just fine. Well, how do you know? Well, that's proprietary. Well, that means he doesn't know. We do a lot of testing. Well, describe those tests, and they're all standards tests, and they're all designed to pass. They very rarely, if ever, get any useful information out of them, and on and on and on. At that point, I really think this discussion's not going anywhere. So let's get a hold of somebody else that understands their product and may want to actually help us get a solution. So the first step is really understand what you want, be willing to talk openly about it, and recognize that their needs may be completely different than ours. Some suppliers just need to know that you're going to buy 100 power supplies per week. That's stability. They can plan for it. They don't have big whipsaws. You're not changing the order every week. It costs them money to redo their systems to meet your demands and so on. They may just want stability. We've got a price. We know how many we're going to sell. We can set up a factory to do that very efficiently. But if it's 1,000 this week and 25 next week, and then it varies in that order all the time, and you only get a 1 week notice on it, then I have to spend a whole lot of extra money as that supplier putting things in warehouses to account for the peak ones. But then I have all this stuff in warehousing costing money. So I'd rather have stability and good delivery cadence and all this other stuff with ample lead time on changes to it, which is not hard for most organizations to provide. In exchange, they will meet our expectations around reliability because it frees up enough money for them to do the accelerated testing work, to do the failure analysis work, to do the physics of failure type research, if they know they've got a stable, consistent business. And that's just one example of what a supplier may benefit from that enables them to meet our needs. If in reliability is the one I'm always interested in, but it's not just pay them more. It's oftentimes these other things like if you're going to do a change, we need to know 3 months in advance because of the lead time it takes for our raw materials. Oh, okay. Well, that makes sense. Can we do that? And yeah, there's exceptions, but let's try to do it in that realm rather than whipsawing them all over the place. So it's one example is what do they need? What is of value to them? And what's of value to us? And how can we both meet those needs and create a business that will be beneficial to both of us? It's kind of, I hate to say it, but it's that win-win kind of thing. Not just lip service to it. If you lower the cost, we both win because we'll keep buying it and that kind of part. So it's now we need to understand what is it they really need. Can we meet that? And then here's what we really need and why. Can you meet that? And then let's work together to find the right solution. So that's it's right at the start, right when you start picking your suppliers. It's are they a viable business? Do they have the technology? Do they have capacity to meet our needs? All those things are all important. Yet, what they need and what they require to be a good supplier to us may be very different than what we want. And it's that relationship of balancing it out at that stage, it sets the stage that we can talk to each other when things fail or when things need to be changed. But it just pulling it out of the catalog and then yelling at them later doesn't really help define a relationship, especially for those critical parts that we need. The other thing that we can do in as reliability professionals is doing an assessment of their program. And Carl and I wrote the book on how to do that and all the stages for setting up a plan. But part of that was the assessment is what are you doing well? What are you not doing so well? How do you make decisions that lead to the reliable outcomes that you're getting? And how consistent are they? So how do they deal with data? How do they deal with failure analysis? How do they deal with design decisions and so on? So offer to spend a day with them, do the interviews, understand their system really well, give them recommendations to make improvements, and if needed, help them achieve it. The investment for an engineer for a week or so of teaching them how to do Weibull analysis, for example, is a small investment in what can become a very profitable business relationship with them. And so spending the time to understand their program, help them improve it, there's nothing proprietary about using an FMEA, for example, efficiently or well, or doing product testing that actually gives you meaningful results. Help them become proactive, help them understand what they're doing well and where they can improve. And where needed, do the training. Where needed, help coach them in doing it. It's a small investment that, especially with a major supplier that you need, um, really does help build a relationship of working together right from the start, right from the design. I often hear, well, we don't want to teach them this because then they sell products to our competitors and they'll get better products. I'm like, all ships rise with the tide. Somebody's got to make the investment. And if we're not getting what we need to take action on it and not wait until Dell or IBM or somebody else teaches them how to do it. Let's do it and move forward and have the strong relationship with them that the others may be missing out on. And the final one is you get a failure. Failures happen. It's what keeps us in business as reliability folks. Is we understand that it will happen and talk about it up front. Who do we need to call or who do we need to get involved to get on the failure analysis team to understand what's happening? What are the possibilities? How do we debug this correctly? How do we sort out where the failure actually is? What kind of mechanisms are we looking for? Who can jump on a call with us and let's work out the fishbone diagram just as a way to get started. And even before that, if we've done FMEAs with them, we both have a better understanding of what could fail. But it's a way to work with the team, the supplying team, such that they want to work with us because they come away a better, they learn something. We learn something because of their insights and background and understanding of the product, but only if they trust us and are willing to talk to us. Vice versa, that means we have to do the same. And so it's really the cornerstone or keystone is if and when failures occur, is we have a solid enough relationship that we can get a good, solid understanding of the failure and what each side needs to do. It may be design changes on our side, it may be design or manufacturing changes on their side. And sometimes it's both. But the idea is that if you don't start the relationship at the start in a clean, clear, commutative way, it's really hard for them to all of a sudden trust you. And so and also if we've been only talking about cost, they don't have the resources more than likely to be able to help us. So the key parts of this is start an open discussion about how and where you're using the product. Yeah, sign some NDAs, but get a relationship where you can talk to them about more than just the contract. Second is work together to get the design right. Third, don't blame them when something fails. It may well not be their problem. Let's both just understand it and then move forward from there. I highly recommend whenever possible for key suppliers for you is do the assessment. It's free to them. It gives them meaningful information. You get a better relationship. You get a better product. You get a better supplier. Those are the key things for this. Let's see. And I think I'm ending this, but it sounds like they got the chipper going outside. So hopefully you can't hear that too much. I think they moved it closer to the house. But hopefully, even if you don't have that perfect supplier, don't have any of them, like Tony mentioned in the chat, maybe you can see a way of doing this. So what do you see as the biggest hurdle to making this happen? I've seen a few of those. I didn't talk about that. Some of the barriers you're likely to get. Let's see. I'll leave it on this slide. I think my next one is other questions and comments. So I'll leave that open for you. But I ended a little bit early. I guess I'm talking too much. I should have asked more questions and got more feedback on it. Um, I usually do. I guess I'm a little bit nervous about how much noise is outside. Yeah, jumping to conclusions. Yeah, I've seen that, Michael, where you're in, say, oh, this power supply failed. Oh, it must be their fault. Not mentioning that you have it in a faulty socket that's giving you, twice the voltage that you in voltage spikes every time the elevator moves. Um, that is the power supply was the victim of a bad something else. Stress is not, it wasn't designed for example. Yeah, it's all too often you pull off the component and go, oh, this is the one that's bad. And I learned it from a client once is that component may well have been the hero acting like a fuse that saved all the expensive components in your system. Or it might have been the victim. It took the brunt of it and just got damaged. It got overstressed. Or it really may be the culprit and that caused the problem and killed itself. But there were a different way of thinking about it is when we, shotgun, replace a handful of components and, oh, it's working. So it must have been one of those. We may have already destroyed the evidence we need to actually figure out what happened. So being pretty cautious about doing failure analysis, not taking parts off right away, is a very good thing. Yeah, Jason, suppliers will do extra testing, yet you can't ask for it for free. And if it's in their best interests, let's say we ask for testing that will help them understand that how their product works in a different kind of stress or in the stresses that we're going to be using. If we're interested in that, maybe we can teach them how to test in such a way that they get a better way of doing accelerated testing, or they get a better, deeper understanding of their product. But if we just ask them to do this gauntlet of various industry standards and don't pay them for it, there's nothing in it for them. They're unlikely to learn anything useful. And they might be scratching their head, why are you even doing these things? Yeah, walking the talk. Yeah, you're exactly right, Stephen. Is you can't just put it on a banner or on a plaque in your conference room. You actually got to do it, right? And yeah, getting them to do something for you, it's like asking your engineering team, hey, you need to change that. And if you don't have a good rationale for why this is going to cause failures or not, it'll harm the reliability of of your product. If you don't have that good solid case in place, why it's beneficial to us in general and good for the customer, the engineering teams, the design team's not going to do it just because you asked for it. They might be, it depends on how good you are. But the idea is that it's the same with the supplier. If we put on requirements, and if it's also in their benefit and they can understand that, we say we want to understand how it behaves under these different electrical loads. We've got ways of doing that. Are you willing to supply some components and send one of your engineers over here to learn how to do it? Now they get a better qualified or additional skill in their team. They get to see a way to understand and interrogate their products that makes their understanding of its reliability stronger. It could be accelerated testing. It could be doing FMEAs. It could be doing things that they're not good at yet. If it's a giveaway to them that they become a better supplier because they're more knowledgeable, they may say, yeah, we'll do that. Now, others won't because they've been burned by these relationships so many times in the past. They get asked to spend $1 million and then we go to a different supplier and they have to eat the cost. Or we've negotiated the price so low that it wipes out all their profit from the supplier customer relationship we've got going. So we got to be cognizant of what's motivating them, where their drivers are, where their margins are, what capabilities they have, and where can we barter our knowledge in some cases and skills and techniques and capabilities such that it helps them. It's not that we want a test, it's that we want we, us and the supplier, would benefit if we learned something. And here's a test that could provide that information. Instead of demanding the test, maybe they've already done it. Maybe they already have that capability. Maybe they haven't revealed that yet. And it goes back to that trust thing. So being open about it and not just demanding things, but saying, hey, here's the problem we're trying to solve. Maybe you have some ideas on this, as opposed to do XYZ test by Friday. Hopefully you see the difference or hear the difference. Yeah, let's see. The balance between is a good question. Julia, sorry, I'm not sure I'm pronouncing that right. What's the balance between trusting the supplier testing and retesting internally? That's a good question. It's if you do the assessment with a supplier and you understand that they really do understand reliability and quality, and they do make decisions based on that, I would trust their testing. Because they probably give you all the data and they'd probably be happy to show you what they're doing. And you can ask them lots of questions about how they went about doing it. And it's a good thing. Is I would trust that completely. Yet I've had suppliers that just say, oh, it's on the data sheet. We do all of these standard tests and they all pass. Well, what happens when it fails? Oh, it never fails. And then talking to the engineers that are doing the testing says, well, anytime one of the samples fails, we just replace it with one that works so that at the end of the test, they're all working. Now, I have little to no trust in their data because I've learned enough about it that no, they're not, they're just doing it to fill the data sheet and they're not even learning anything themselves on it. But if you can't tell me what's likely to fail and how do you know, they've got a long ways to go. And it's probably because they're a victim of that typical supplier relationship for way too long. So doing the assessment gets you a really good idea of what they do well and what they don't do well. And some suppliers, many suppliers, actually do a really good job. Yet if you negotiate such a low price, they're not going to answer the phone. It costs too much. And so it starts really early. But if it's absolutely totally critical and it's interacting with your design, they may not be able to test it internally to meet the set of stresses that we're putting their component under. So internally testing is our only way to do it on our prototypes and within our design and system. But if we're willing to send them the boards and have them run the testing because they have a better capability of checking, say, their power supply's performance than we do, well, let's do that. But we may have to pay for it. That's okay. We may have to help them with data analysis or in some other part of the system, maybe even process control, help them really understand process control and control charts and stuff like that. In exchange, could you guys run this test in this way? So because you have the capability to do it. A bit of give and take goes a long way. All right. Well, I'm at the top of the hour and I'll keep the session open if there's any more questions and stuff like that. Thanks for the questions at the end here. Thanks for joining today. I'm going to go ahead and close off the recording.